Shall we start? Now it is. So in last class, am I audible? Anyone?
Yes, sir.
Yes, sir.
Hello?
Sir.
Yes. Okay. So in last class, we have seen the basic first model. Remember, there will be vector x always representing input, then vector w, it will be a weight vector, or it will be matrix if there are many neurons. So always you will compute O equal to f of net. So that will be calculated here, and net is equal to W transpose X, and this is activation. Okay, so this sum is applied to the activation function and it will produce the output. So this will be the general mechanism of a neuron. Then we have seen that this activation function for Mculloch-Pitts model is like this. This is a thresholding function where I can say this is t equal to 0 in this case. So whenever your input, that is net here, is greater than equal to 0, this will fire. It will produce 1, otherwise it will produce 0. So output here is 0 or 1. Inputs are zeros or ones. And weights in this particular network, or sorry, neuron, is always +1 or -1. Depending on your logic, you will decide these values. Then we have seen some example like NOT gate, then NOR gate and NAND gate. Have you solved this homework? You tried? Anybody?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. And this was your second homework. Then we have seen very briefly what do you mean by learning rules. So what is learning rule? It is the provision or a way to find out W for a given problem. So this will automatically find out what W vector should be so that your problem is solved. In earlier case, this W was obtained by your own knowledge, with the help of your own knowledge. But I want to obtain this W automatically. So this is the main aim behind proposing these rules. The general form to obtain weight vector is like this. This W old is initial guess. This will be assumed randomly. Since I don't know the W, I will assume it randomly. Then I will compute delta W based on certain rule. So this will be my rule. Once you compute delta W, that will get added to old W, and that will give you new W. So this will be done for every pattern or every input sample, or it is called as training data. So we will see the procedure. So if you try to categorize learning rules, you can categorize with the help of certain things, that is supervised, unsupervised. So you will learn with teacher, learn without a teacher. So unsupervised means learning without teacher on your own. Supervised is learn with a teacher. So this is one category. Another way is competitive learning. So this is kind of unsupervised. And reinforcement learning. So this is getting popular these days. Reinforcement learning means you will be given some data. Your neural network get penalty if your answer is wrong, and if your answer is correct, there won't be any penalty. So that kind of learning is called as reinforcement learning. Another way to categorize is online or incremental, offline or batch processing. Incremental means you will apply your training samples one by one. And batch means you will learn with a batch of samples. Okay, so certainly there are some advantages and disadvantages of each group. The very first learning rule is called as Hebbian, proposed by Hebb in 1949. So what this Hebbian learning rule is, it is inspired from biological neuron. What it says, if an input from a neuron A is repeatedly and persistently causing the neuron C to fire, a metabolic change takes place in the synapse of that particular input to increase its efficiency as the one of the cells firing neuron C. So what it means, suppose this is input node of this neuron and say A, and this is neuron C. So there is some input which is coming from previous neuron, and this input is helping this C to fire. If this is the case, then this C will increase weight here. Suppose this is W1 and say this is W2. Then W1 will keep on increasing if this neuron A continuously fires C. If suppose neuron B is triggering this C in opposite way, it is not helping neuron C to fire, then the weight will go down. So weights will increase if the previous input fires this neuron C. Weight will decrease if previous neuron is not allowing C to fire. So that was the concept. This is called as Hebb's rule. So rule is the function of W transpose X. So change in weight for a particular connection Wij. Now remember, if this is x1, x2, suppose x3, x4, and so this is ith neuron, I will write this as Wi1, Wi2, and so on up to Win. So when I say Wij, you can assume, suppose this is the jth connection, then this becomes Wij. So this Wij, change in Wij is equal to Cox. Or if I write in terms of instead of this, so W nu is equal to Cox. So this is my say delta W is equal to Cox. This is my Hebb rule. We'll see this with example. I can note down this problem. Say let there are 4 training samples. There are 4. Okay, in this case there are 3 training samples and 1 weight. Now question is, train the following neuron using Hebbian learning rule. Initial weight and training samples are W1, X1, X2, X3 respectively. Assume a sign activation function. Okay, so this is my single neuron with sign activation function. Then I have 3 inputs. I don't know what is required weight, so I am just assuming 1 minus 1 0.5. So 1 will be placed here, minus will 1 go here, then 0, then 0.5. Okay, now what is procedure? The procedure is, you will first of all find out net 1 for input x1. So here I am taking this first input. So net 1 is W transpose x1, or in this case W1 I can say. So what is W1 transpose? It is 1 minus 1 0.5. So I will write here 1 minus 1 0.5. This will get multiplied with x1. So x1 is 1 minus 2, 1.50. Can you type? What is this? Anybody? Okay. So net 1 is 3. This will go to neuron as input, and output, suppose output 1 is equal to f of 3. Now f is sine function, so my output is plus 1. Is this understood?
Yes, sir.
Is this fine? Anyone?
Yes, sir.
Yes, sir.
Okay. So net 1 is 3 and corresponding output is plus 1. Now this W1 is added with this delta W. Now this delta W in this case is equal to COX1, O1 x1. This c is a learning constant defined by user. So let us assume in this case, suppose c is equal to 1. So c is equal, so what will be change in weight? So 1 into output is 1 multiplied by x1. So 1 minus 2, 1.50. So W2, this is the fresh copy of weights for this neuron, is W1 plus delta W. Okay. So W2 is computed like this. This is my W1. This is change in weight computed by Hebbian. And this will give you fresh copy of weight matrix, weight vector. So this W2 now will go to this place. Okay. Now what you have to do is you take now x2 and repeat this procedure. Can you do this? So you started with W1, you will obtain W2. From W2 you will obtain W3. So from here to here you will use x1. From here to here you will use x2, and to compute W4 you will use x3. So with these three samples you will compute W4. So this will be my first iteration. Okay. So with this W4, if I stop training, assuming that I am stopping training after one iteration, then that becomes my final weight. So with this final weight, if I apply now x1 to neuron, it will produce +1. For x2, it will produce -1. For x3, it will produce -1. So thing is, you must understand these steps. If this is not clear, I will repeat now itself. This will be there throughout the course. So you try to understand the basic steps. Shall I repeat?
Yes, sir.
Anybody?
Yes, sir.
Can you speak? Anyone?
Yes, sir.
Is this fine or shall I move further? Ganesh, are you there?
Yes, sir.
Hello.
Yes, sir.
Uh, you-
Continue, sir.
just 1 second. Yeah. So your voice was not audible. Can you repeat?
Sir, last step not clear.
Okay. Now see, you were provided this initial weight. This was guess. This is not a solution. Now what we want to do is we want to refine this W1 as per given rule, that is Hebbian rule. And these are training samples. Okay. Now we start. Let me write here. We started with W1, then we used X1 and then obtained W2. Then we take this W2, used X2 to find out W3. Then we take W3 as fresh copy of weight, then use X3 and compute W4. This is what we are doing. So once all inputs are exhausted, I say this is first iteration. Is this fine up to this point? Anybody?
Yes, sir.
Okay. So starting with W1, you go up to W4. What I want to say is, if you say I will stop for the first iteration, then whatever is your W4, that will go here. That will reside here. Okay. Then I say my neuron is trained. So no further changes in weights will be done. So yeah, now suppose you place this W4 here on these connections. Then suppose I apply X1. Then what will be output of this neuron? This will be O is equal to, say, sine of net, where net will be W4 transpose X1. Okay, so this will be computed with the help of fresh copy of weight always. Then if I want that what this neuron produces for X2, then I will calculate again net W4 transpose X2. Then if I want for X3, then I will again calculate net W4. So this, you see, this W will not change because I have stopped training. Okay. So once you compute these nets, you can appropriately compute corresponding outputs using this equation. Now, if these outputs are not satisfying your certain criteria, you can repeat this training. You can enter into next iteration. So like that, you can repeat all this procedure. You can decide number of iterations. So this repetition is iteration. A neural network will be evaluated after every iteration with the help of certain fitness function. If that is satisfied, you will stop training, otherwise you will repeat. So this is what is happening in any kind of network.
Sir, how next iteration will be done?
Okay, this is a very good question. So what we have to do is as I said, you started with W1 with 3 samples. You reach to W4. This is my first iteration. Now when I want to go to second iteration, I will take W4 as my latest copy of weights and then use again 3 samples, same samples, this one. Okay, so what will be then my weight, final weight? So with W4 with X1 you will compute W5, with W5 X2 you will compute W6, with W6 X3 you will compute W7, and that will be your final weight. If you want to repeat again, then you will go with W7 as new copy, then again 3 samples. Okay, so it will be maybe W10. So you can go on doing this. You can evaluate with a fitness function. If you find it is giving you required result, you can stop. Maybe this will be your final. If you wish, you can use this example and do your own iteration one more time. Would you like to do? You can tell me the answer. Use W4 as initial that you have calculated. Okay, here I am giving you W4. This is my output after one iteration. Use this W4, use these training samples once again to compute W7. Would you like to do or shall I move?
We will do at home, sir.
Okay. I hope everyone has understood this.
Yes, sir.
Okay. Now, this rule, I'm just repeating, delta W is equal to COX, where C stands for learning constant defined by user. O is output of neuron, X is input to the neuron. So this is the rule, Hebbian learning rule. Here, the rule is unsupervised, as there is no teacher signal. So what is teacher signal? We will see in this next learning rule, which is given by Perceptron. It's done. Now we are moving to this. This was unsupervised. And the next rule, which came in 58 after 9 years, is supervised. So Rosenblatt gave this rule in 58. They proposed the first one. The first, I think, mathematical model came in 46 or 47. That is Mculloch and Pitts model. without any learning. So this was without any learning. Then first rule 49 and second rule is 58. So they have done a small thing. So here now change in weight is equal to learning constant. So D minus O into X. So D minus O into X. If I'm talking for ith neuron, then I will write here Di minus Oi into X, where Di stands for desired response of ith neuron, and Oi stands for output of ith neuron. X is as usual input. C is learning constant. Okay. So if we compare with previous one, it was COX Hebbian. Now it has changed to C into D minus O into X. So they have added only this term. It took 9 years to do this. This is Heb, this is Perceptron. And this was very popular, and this made neural network popular in those days. And still we are using a form of this rule only. Okay. So rule is D minus R, OI, or DI minus OI. So change in weight. What is O now in this case is a sine function that we have seen earlier. So OI is a sine function of W transpose X. For ith neuron, I will write here WI. So OI is either plus 1 or it is minus 1, because this is sine. And desired response for a neuron is plus 1 or minus 1 depending on your requirement. For x1, suppose I want output should be plus 1, then for input x2 I want output should be minus 1, say for x3 output should be plus 1. So this is my requirement, this is my problem. So this plus 1 minus 1 is indicating class of a sample. Okay, so what is class? Suppose I want to train a neuron for pen and suppose duster. So I will assign plus 1 to pen. So whenever neuron want to indicate that I have seen a pen, then it will output plus 1. Whenever it sees a duster, it will produce minus 1. So this is basically doing classification of two classes. So a perceptron can solve two class problems. So how to solve multiple class problem or multi-class problem, that we'll see in subsequent lectures. The simple thing is a two-class problem that we will see. Now we'll take one example. Say x1 is equal to this 1 minus 2 0 minus 1 and so on. Now for each input there is corresponding desired response. Say for x1 I want minus 1, for x2 I want minus 1, for x3 I want plus 1. Learning constant was kept as 0.1. Now let assume that the perceptron is having a weight vector w1. So w1 is 1 minus 1 0 0.5, same as previous, but here we are supplying d for each input. So net 1 is same as previous one, w transpose x1. So this will be sum 2.5. Yes, okay. Then change in weight is computed using perceptron learning rule. So C is 0.1 multiplied by desired response of first sample is -1, and actual output here is sine of 2.5 is equal to 1. So I am not obtaining what I want. I am obtaining +1, but I want -1. So D1 is -1, but O1 is +1. So my neuron is not properly producing required output. So if I put here D is equal to -1, O is equal to +1. So my rule is C into D minus O into X. Okay. So here I'm writing that into X1. X1 is 1 minus 2 0 minus 1. So this will give me change in weight. This change in weight I'm going to add with initial guess. That will give me W2. Okay, so if I do that, then I'm going to get this W2. So in next step, we will use X2 and find out W3. Then I will use X3 to get W4. So for timing, I will stop here. You just try to find out these values. I will tell you answer tomorrow. So shall I stop? Any problem? Any query? Okay, thank you.